A solstice is an astronomical event that occurs twice each year as the Sun reaches its highest or lowest excursion relative to the celestial equator on the celestial sphere. The solstices, together with the equinoxes, are connected with the seasons. In many cultures the solstices mark either the beginning or the midpoint of winter and summer. The word solstice is derived from the Latin sol and sistere, because at the solstices, the Sun stands still in declination. That is, the seasonal movement of the Sun's path comes to a stop before reversing direction. At latitudes in the temperate zone, the summer solstice marks the day when the Sun appears highest in the sky. However, in the tropics, the Sun appears directly overhead some days before the solstice and again after the solstice, which means the subsolar point occurs twice each year. The term solstice can also be used in a broader sense, as the date when this occurs. The day of the solstice is either the longest day of the year or the shortest day of the year for any place outside of the tropics. Definitions and frames of reference: for an observer on the North Pole, the Sun reaches the highest position in the sky once a year in June. The day it happens is called the June solstice day. Similarly, for an observer on the South Pole, the Sun reaches the highest position on December solstice day. When it is the summer solstice at one pole, it is the winter solstice on the other. The Sun's westerly motion never ceases as the Earth is continually in rotation. However, the Sun's motion in declination comes to a stop at the moment of solstice. In that sense, solstice means sun standing. This modern scientific word descends from a Latin scientific word in use in the late Roman Republic of the 1st century BC, solstitium. Pliny uses it a number of times in his Natural History with a similar meaning that it has today. It contains two Latin language morphemes, sol, sun, and stitium, stoppage. The Romans used standing to refer to a component of the relative velocity of the Sun as it is observed in the sky. Relative velocity is the motion of an object from the point of view of an observer in a frame of reference. From a fixed position on the ground, the Sun appears to orbit around the Earth. To an observer in an inertial frame of reference, the planet Earth is seen to rotate about an axis and revolve around the Sun in an elliptical path with the Sun at one focus. The Earth's axis is tilted with respect to the plane of the Earth's orbit, and this axis maintains a position that changes little with respect to the background of stars. An observer on Earth therefore sees a solar path that is the result of both rotation and revolution. The component of the Sun's motion seen by an earthbound observer caused by the revolution of the tilted axis which, keeping the same angle in space, is oriented toward or away from the Sun. Is an observed daily increment of the elevation of the Sun at noon for approximately 6 months and observed daily decrement for the remaining 6 months. At maximum or minimum elevation, the relative yearly motion of the Sun perpendicular to the horizon stops and reverses direction. Outside of the tropics, the maximum elevation occurs at the summer solstice and the minimum at the winter solstice. The path of the Sun, or ecliptic, sweeps north and south between the northern and southern hemispheres. The days are longer around the summer solstice and shorter around the winter solstice. When the Sun's path crosses the equator, the length of the nights at latitudes plus la degree and la degree are of equal length. This is known as an equinox. There are 2 solstices and 2 equinoxes in a tropical year. Relationship to seasons. The seasons occur because the Earth's axis of rotation is not perpendicular to its orbital plane but currently makes an angle of about 23.44 a degree, and because the axis keeps its orientation with respect to an inertial frame of reference. As a consequence, for half the year the northern hemisphere is inclined toward the Sun while for the other half year the southern hemisphere has this distinction. The 2 moments when the inclination of Earth's rotational axis has maximum effect are the solstices. At the June solstice the subsolar point is further north than any other time, at latitude 23.44 a degree north, known as the Tropic of Cancer. Similarly at the December solstice the subsolar point is further south than any other time, at latitude 23.44 a degree south, known as the Tropic of Capricorn. The subsolar point will cross every latitude between these 2 extremes exactly twice per year. Also during the June solstice, places on the Arctic Circle will see the Sun just on the horizon during midnight. and all places north of it will see the sun above horizon for 24 hours. That is the midnight sun or midsummer night's sun or polar day. On the other hand, places on the Antarctic Circle will see the sun just on the horizon during midday, and all places south of it will not see the sun above horizon at any time of the day. That is the polar night. During the December solstice, the effects on both hemispheres are just the opposite. This also allows the polar sea ice to increase its annual growth and temporarily extend at a greater level due to lack of direct sunlight. Cultural aspects, ancient Greek names and concepts. The concept of the solstices was embedded in ancient Greek celestial navigation. As soon as they discovered that the Earth is spherical, they devised the concept of the celestial sphere, an imaginary spherical surface rotating with the heavenly bodies fixed in it. As long as no assumptions are made concerning the distances of those bodies from Earth or from each other, the sphere can be accepted as real and is in fact still in use. The stars move across the inner surface of the celestial sphere along the circumferences of circles in parallel planes perpendicular to the Earth's axis extended indefinitely into the heavens and intersecting the celestial sphere in a celestial pole. The Sun and the planets do not move in these parallel paths but along another circle, the ecliptic, whose plane is at an angle, the obliquity of the ecliptic, to the axis, bringing the Sun and planets across the paths of and in among the stars. Cleomedes states, the band of the zodiac is at an oblique angle because it is positioned between the tropical circles and equinoctial circle, touching each of the tropical circles at one point. This zodiac has a determinable width. That is why it is described by three circles. The central one is called heliacal. The term heliacal circle is used for the ecliptic, which is in the center of the zodiacal circle, conceived as a band including the noted constellations named on mythical themes. Other authors use zodiac to mean ecliptic, which first appears in a gloss of unknown author in a passage of Cleomedes where he is explaining that the moon is in the zodiacal circle as well and periodically crosses the path of the sun. As some of these crossings represent eclipses of the moon, the path of the sun is given a synonym. The ecliptic goes from eclipsis, eclipse. English names. The two solstices can be distinguished by different pairs of names, depending on which feature one wants to stress. Summer solstice and winter solstice are the most common names. However, these can be ambiguous since seasons of the northern hemisphere and southern hemisphere are opposites, and the summer solstice of one hemisphere is the winter solstice of the other. The Latinate names estival solstice and hibernal solstice are sometimes used to the same effect, as a midsummer and midwinter. June solstice and December solstice are an alternative to the more common summer and winter terms, but without the ambiguity as to which hemisphere is the context. They're still not universal, however, as not all people use a solar-based calendar where the solstices occur every year in the same month, and the names are not useful for other planets, even though these planets do have seasons. Northern solstice and southern solstice indicate the hemisphere of the sun's location. The northern solstice is in June, when the sun is directly over the Tropic of Cancer in the northern hemisphere, and the southern solstice is in December, when the sun is directly over the Tropic of Capricorn in the southern hemisphere. First point of Cancer and first point of Capricorn. One disadvantage of these names is that, due to the precession of the equinoxes, the astrological signs where these solstices are located no longer correspond with the actual constellations. The solstices are currently in the constellations of Taurus and Sagittarius. Solstice terms in East Asia. The traditional East Asian calendars divide a year into 24 solar terms. Xiaza or Geshi. Vietnamese, Ha Ka. Literally, summer's extreme is the 10th solar term, and marks the summer solstice. It begins when the sun reaches the celestial longitude of 90° and ends when the sun reaches the longitude of 105°. Xiaza more often refers in particular to the day when the sun is exactly at the celestial longitude of 90°. Da Ng Zha or Ta Ji. Vietnamese, Aang Ka. Literally, winter's extreme is the 22nd solar term, and marks the winter solstice. It begins when the sun reaches the celestial longitude of 270° and ends when the sun reaches the longitude of 285°. DNGZHA more often refers in particular to the day when the Sun is exactly at the celestial longitude of 270 degree. The solstices mark the middle of the seasons in East Asian calendars. Here, the Chinese character E cubed means extreme, so the terms for the solstices directly signify the summits of summer and winter. Solstice celebrations. The term solstice can also be used in a wider sense, as the date that such a passage happens. The solstices, together with the equinoxes, are connected with the seasons. In some languages they are considered to start or separate the seasons. In others they are considered to be center points. Similarly, December 25th is the start of the Christmas celebration, and is the day the sun begins to return to the northern hemisphere. Many cultures celebrate various combinations of the winter and summer solstices, the equinoxes, and the midpoints between them, leading to various holidays arising around these events. For the southern solstice, Christmas is the most popular holiday to have arisen. In addition, Yorda, Saturnalia, Karashon, Hanukkah, Kwanzaa and Yule are also celebrated around this time. For the northern solstice, Christian cultures celebrate the Feast of St. John from June 23 to 24, while neo-pagans observe Midsummer, also known as Litha. For the vernal equinox, several springtime festivals are celebrated, such as the Persian Nowruz, the observance in Judaism of Passover and in most Christian churches of Easter. The autumnal equinox has also given rise to various holidays, such as the Jewish holiday of Sukkot. At the midpoints between these four solar events, cross-quarter days are celebrated. In the southern tip of South America, the Maypuk people celebrate Huitripantu a few days after the northern solstice, on June 24. Further north, the Atacama people formerly celebrated this date with a noise festival, to call the sun back. Further east, the Aymara people celebrate their new year on June 21. A celebration occurs at sunrise, when the sun shines directly through the gate of the sun in Tiwanaku. Other Aymara New Year feasts occur throughout Bolivia, including at the site of El Fuerte de Samaipata. In many cultures, the solstices and equinoxes traditionally determine the midpoint of the seasons, which can be seen in the celebrations called midsummer and midwinter. In this vein, the Japanese celebrate the start of each season with an occurrence known as Setsubon. The cumulative cooling and warming that result from the tilt of the planet become most pronounced after the solstices, leading to the more recent custom of using them to mark the beginning of summer and winter in most countries of Central and Northern Europe, as well as in Canada, the USA and New Zealand. In the Hindu calendar, two sidereal solstices are named Makara Sankranti, which marks the start of Uttarayana, and Karkat Sankranti, which marks the start of Dakshinayana. The former occurs around January 14 each year, while the latter occurs around July 14 each year. These mark the movement of the Sun along a sidereally fixed zodiac into Makara, the zodiacal sign which corresponds with Capricorn, and into Karkat, the zodiacal sign which corresponds with Cancer, respectively. Solstice determination. Unlike the equinox, the solstice time is not easy to determine. The changes in solar declination become smaller as the Sun gets closer to its maximum-minimum declination. The days before and after the solstice, the declination speed is less than 30 arcseconds per day, which is less than 1/60 of the angular size of the Sun, or the equivalent to just 2 seconds of right ascension. This difference is hardly detectable with indirect viewing-based devices like sextant equipped with a vernier, and impossible with more traditional tools like a gnomon or an astrolabe. It is also hard to detect the changes on sunrise-sunset azimuth due to the atmospheric refraction changes. Those accuracy issues render it impossible to determine the solstice day based on observations made within the 3 days surrounding the solstice without the use of more complex tools. Accounts do not survive, but Greek astronomers must have used an approximation method based on interpolation, which is still used by some amateurs. This method consists of recording the declination angle at noon during some days before and after the solstice, trying to find 2 separate days with the same declination. When those 2 days are found, the halfway time between both noons is estimated solstice time. An interval of 45 days has been postulated as the best one to achieve up to a quarter-day precision, in the Solstice Determination. In 2012, the journal DIO found that accuracy of 1 or 2 hours with balance errors can be attained by observing the Sun's equal altitudes about S equals 20 degrees before and after the summer solstice, because the average of the two times will be early by Q arc minutes, where Q is /3 times the square of S in degrees, and the noise in the result will be about 41 hours divided by D if the eye's sharpness is taken as 1 arc minute. In the constellations, using the current official IAU constellation boundaries Euro, and taking into account the variable precession speed and the rotation of the ecliptic Euro, the solstices shift through the constellations as follows. The northern solstice passed from Leo into Cancer in year 1458, passed into Gemini in year 10, passed into Taurus in December 1989, and is expected to pass into Aries in year 4609. The southern solstice passed from Capricornus into Sagittarius in year 130, is expected to pass into Ophiuchus in year 2269, and is expected to pass into Scorpius in year 3597. Solstices on other planets. Due to the 687-day orbit of Mars around the Sun, the planet experiences its summer and winter solstices at approximately 23-month intervals. The most recent northern summer solstice on Mars was on February 15, 2014, and the next will occur on January 3, 2016. See also. References. External links. Do your own test. Elevation. The Solstice Amateur. 2001. Retrieved March 7, 2009. Earth's Seasons, Equinoxes, Solstices, Perihelion, and Aphelion, 2000 Euro 2020. United States Naval Observatory, Astronomical Applications Department. Weierstein, Eric. Summer Solstice. Eric Weierstein's World of Astronomy. Retrieved October 24, 2008. The above plots show how the date of the summer solstice shifts through the Gregorian calendar according to the insertion of leap years. Gray, Meehan. Merrifield, Michael. Solstice and Equinox. 60 Symbols. Brady Heron for the University of Nottingham. Solstice and Equinox in Pennes de Rodas.